Hey everybody, this is Larry. This is day 10 of the March Leetcode Daily Challenge, the Mario Day, right? Huh. Hit the like button, the subscribe button, join me on Discord, let me know what you think about today's poem. Yeah, Mario Day because it is March 10th, just Mario. But let's jump into this problem. I just finished doing my 10K easy one. So I'm a little bit tired. Just took a shower and all these things, but yeah, just getting ready for this weekend's marathon. So let's take a look at today's poem. I think this is part 2 of yesterday's. So definitely, if you haven't seen yesterday's, then watch yesterday's poem. And I don't know that I explained it super well yesterday because I kind of got confused at the implementation a little bit, but. But you can also watch, if you search for this under, YouTube's and my name. I think I did this during a contest a while ago. How long ago was it? Yeah, like 2 years ago. And I probably had a good explanation then. But yeah, the key part about this, let's actually, let's copy and paste here. I mean, of course, this is going to be too slow because n is now 1,000. Right, and 1,000, right? So you can't do 100, because we did the math here, and this is a continuation, of course, of yesterday's code. So like I said, that's why you need, or if you prefer, you watch yesterday's. But yeah, if you can't do the math, we already did the complexity, right? It's gonna be 200, 200, and then L is also 200 for yesterday's problem. Today it's gonna be 1,000, and we have 1,000, 1,000 is gonna be too slow. So what can we do, right? The first thing that the thing that we want to look at, right, is for these kind of problems is visualization. That's the thing that I recommend, right? And for that, I am bringing up the drawing board. So hold on for a second, not hang up. What is it? Hold up. Yeah, I wanted to say hold up and hang on, and then I just say hang up. But but yeah, it's just on screen. It is not on screen. Okay, so the idea about this, actually, let me take this off for a second, right? Is that we look at the code. We have the dimensions of zeros, zeros left, ones left, and last used, right? Last used, makes it like a 3-dimensional thing, but that's for the sake of this one, because I cannot draw 3-dimensional easily. Just do a 2-dimensional thing, right? Because then now you have basically 2-dimensional matrices. Maybe draw them slightly cleaner. You have 2-dimensional matrices, right? One is of last use is equal to 1. Last use is equal to 0. Sorry, and I put it in the bottom. Last use is equal to 0 and 1, right? And then of course, maybe your matrix, you'll fill it out. This way it is ones, and vertically is number of zeros, right? Okay, so then now what are we trying to do? Well, let's look at the code again, right? This is from yesterday. The code is from yesterday. Then 0 left. So I mean, on the way that we actually structured this, we can actually split it into 2 functions, which may be a little bit cleaner, because you can because if last used is 0, then you only do this code, right? So without loss of generality, let's say last used is 0, and we only look at this part, right? And we're only trying to use a 1. Well, what does this do? Well, now bringing back the visualization, so we say the last use is 0. Oh, I didn't bring it back. Let's say the last use is 0. So okay, let me change the color real quick. So we're looking at this matrix, right? And let's just say we're here in the core thing, right? So then now what does that mean? That means that here we are looking at, in a for loop, streak is equal to 1, streak is equal to 2, ... right? And what does that mean? That means that given the zeros and ones, this actually wants the sum, this cell wants the sum of, last use is equal to 1 of, let's just say, I don't know, let's just say, or let's say this corresponds to this one, with the only difference is that the last use is 1 instead of 0. Then now, change colors. This thing is the sum of this thing, right? Maybe. And where the length of this is equal to streak, right? And that's it. And this is the visualization of the core graph, right? It's a little bit more complicated than our usual one just because it's 3-dimensional, so it's a little confusing. You can maybe like superimpose it. Like if you impose this back to here, you can see that it's like here or something like that, where, you know, if streak is equal to 1, then it oh, actually I messed this up, didn't I? Huh. Sorry, friends. Sorry. I think I was thinking of a different thing. So yeah. I messed up the visualization, but I mean it's very similar. But I just kind of, you know, when you try to do these things, you should be as precise as possible, or at least, you know, just be correct. So actually, this those zeros don't change, right? Because we're using the next one's gonna be ones, so we want to use ones, so we don't change zeros. So that means that this actually. This match. What is going on? This matches this streak instead, right? Where this is the length of this is streak, right? And you could kind of, it's not my fault for misdrawing, but you could kind of figure out, right? For example, if there are, if this represents 5 zeros and 4 ones, say, then now. You know, this is, and let me change the colors actually. Then this is 5 zeros, 3 ones, 2 ones, and so forth. I mean, we ran into negative because I drew too many boxes, but you get the idea, right? Okay, so now we have the visualization. And let's pretend it is more correct now. It's very precise. You could just say this is 14. Maybe that's a little bit better. Because then there's 13 and 12. And then you won't say go into negatives. Okay. So then now what? What do we do with this visualization, right? We do a visualization is, at least for me, this is how I think about it. We do a visualization. Now what? Well, now what we want to do, we see that, and the streak is limit, right? Is equal to limit. And then and every one of these we would do a for loop right now, right? Well, what if we pre-process this in a way such that we don't even have to pre-process technically, but we just call them in a way such that we take advantage so that we can do it in more O of 1 instead of O of L, where L is the streak or limit or whatever, right? And this is where, now that you have this visualization, you can now think of it, or I mean, maybe you could do it, jump ahead, but it takes me this visualization into a prefix sum, right? Because if you look at this, you know, let's draw. Okay, let's say we got this now, right? Let me reset. Then now we change the problem. Now we have the visualization. We change the problem of, okay, well, we want to be able to get a sum of these numbers in O of 1 time, or log n, I suppose is fine too, but for this, O of 1 time, right? Well, what can we do? Well, we just use prefix sum, right? Because now this is just equal to 2 rectangles, the differences between 2 rectangles, right? Of this rectangle and minus this rectangle, right? I'm gonna just shade it in. So to get this one, you just take the pink thing minus this thing, and then there's your answer. And if you're able to do this one in O of 1, this one in O of 1, then now you're able to do this in O of 1. Okay. I know that was a little bit long. You could have fast forwarded anyway, but I just want to get you the foundation of what we're doing, because I feel like sometimes it does look magical. And I have seen somewhere on my Discord or my YouTube comments or whatever, where people are like not my YouTube comments, because I think I explained it okay last time. But just like on Discord and other places where people are like, well, you could represent this as the delta of two things, but I don't know why you explain it as the delta of two things. Well, this is the basis. This is why I spent so much time on the visualization, is because then now, with this visualization, you can tell why this is two deltas, right? I'm not going to quite write it that way because I want to keep the structure, right? But we could just use a helper function, right? So, yeah. So maybe, I'm trying to think about variable names, but you can just say, let's say we have another function g, right? We could even define g real quick. We have zeros left, ones left, last used, right? Same-ish thing, except for now. Maybe I can do it this way, or not quite like this. I think we have to do it with g1 or or g0, say, right? And g0 is just for this function. It's going to represent the function, the sum of the functions f of zeros left, ones left, last used, plus this -1, -2, plus ... Maybe people usually write the other way actually for prefix sum, plus ... all the way to f of 0, ones left, last used, right? And that's it, right? Because now with this sum, we are able to subtract out the streak to get the answer, right? So, okay, let's fill this out right now. How do we write it, right? Well, we could just write it recursively, right? If, yeah, if zeros left is greater than 0, then we return g0 of zeros left -1. Wait, do I don't know if I return yet, but so basically if it's greater than 0, oh yeah, no, then count we add it to this, and we also count we add just in general f of zeros. I suppose 0 is wrong. Maybe I'm spelling it wrong now. I never could tell. Ones left, last used, and then we return count. And also I didn't finish writing this. I don't know why. Right? And that's it, right? And this basically expands out to this, right? This is just a recursive way of writing it. And the reason why we want to write it, I write it recursively, is because then now we can take advantage of this being cached, right? So that this is O of 1 for whatever. And that's basically the idea. Add it to the cache clear, right? And then now, I mean, of course, you also want to do it with G1 so that you have one that does it similarly, but -1, -2, ... on the ones left. But here we'll jump ahead for a little bit. Where here then now, count is just equal to, or plus equal to, G0 of zeros left. Yeah. Ones left 0 minus G0 zeros left minus maximum streak, which is actually this thing here, right? Or so it's either, well, it's either 0 as your max, so it's max of either 0 or zeros left minus streak, or minus limit. Sorry, I think it's minus limit. It's either minus limit or minus limit plus 1 or -1 or something. Because okay, so let's look at this formula, right? So streak can go to limit inclusive, so then that means that we want to include zeros left minus streak, which means that we're going to subtract out -1, right? Okay. So we want to subtract that out. This may be wrong though, actually, because if this is 0, then we still yeah, let's write this a little bit differently. Actually, we just want to write if 0's left minus limit -1 is greater than equal to 0, then we do this. Okay, that makes more sense, I think. Because because this particular formula, if you call it with 0, then actually it subtracts out the 0 case, which is not what you want. Okay, so then we have with this 1's left, and then 0 is your last used. Yeah, so maybe the last use is always the same if it's going to be 0, right? Because you only call this if I mean, I don't think it changes anything, but I don't think this will be ever a 1, because it doesn't make sense otherwise. Because the 1 would call its own thing, because you don't want, for the using 1, you don't do a subtract on 0 anyway. Anyway, we can finish writing it, but you know, we can just run it real quick. And wait, what? Huh, 3, 2. My output is bigger than it should be. I think we had the same answers yesterday, so that means that I'm off by 1 here, I think. Oh, no. Oh, yeah. Because this should be at least 1, right? So this should be -1, because you're adding this inclusion of, yeah, okay. So this looks good. I'm going to do a quick submit, but no, okay, I won't. I was going to be like, I could do a quick submit to show that it's still correct, but it will time out. But we don't need to do that. We'll just write it out. But yeah, we won't do the same here. But now the difference is that we want to write G1, right, which represents the sum of the functions. So now it's this plus this -1, right? Plus this -2, right? Dot plus f of 0's left, 0 last used, right? And again, maybe last used will always be the same, but I think it doesn't really matter that much. And that's it, right? And here we write basically very similar code. Right, and that is it. Oh, well, we have to fix this, but yeah, but now we use the same idea, right? And now you see why people do the subtraction thing. Oops, almost typoed it. Why not cache? No, it's cache. So why is it so slow? I mean, we could add a cache clear, but I don't think that changes enough. Because we didn't submit it. This was just on the test cases, right? Do I have a typo? Maybe I have a typo. Is there one here? I mean, it looks similar, right? So why is this? All of a sudden, I'm now very confused, honestly. Dun dun dun. Why is this all of a sudden time limit exceeded? Huh? What? I just want to sleep. Please lie down. But why? I mean, it's probably because I have a typo somewhere, but it is very annoying to find. This should be okay. Did I mess up? Huh? What was it before? Right? This was. Trying to undo. Well, this works. So what did I do? So there's a typo here, probably. Well, it's either typo here or typo in the thing. But I mean, obviously this will give us the wrong answer. But if this time limit exceeded, that means that this high. But then why doesn't this fail? Huh. That means G1 as well. Do we put G1? I mean, the reason why it's time limit is probably because we have like negatives in here. But how can that be possible? I guess it just didn't come up in the examples. I mean, the reason why this is a little. I mean, I see it, but because we just don't got it. But I don't know why it wouldn't happen here. I guess it just didn't come up in the examples. But because then what happens is that this causes this when this is 0, then this is -1, and then it just does crazy things. But I mean, we can run it real quick. Yeah, I mean, it's the wrong answer because we add stuff and then we didn't subtract stuff and then we have 2 loops. But that's kind of sloppy, but okay. Okay. Now we'll do a quick submit. Hopefully we didn't miss a case or miss some edge things. And hopefully it is fast enough. It may still be a little bit slow because we're doing this top down as a visualization thing. But we can definitely do this bottoms up. Right? But yeah, but that's basically the idea. Almost, but not yet. I guess we should have tested this. This is easy. Like we could have ran this in there. But let me see how if this is soon enough. That's annoying though. 2 points. So I mean, it is. So I mean, what is clear, maybe, maybe not. I don't know. Is that they're inconsistent and it is somewhere is using the sum of execution time. You know, I thought that they said they don't anymore, but clearly, you know, this when you know, this is a function of how many test cases put. But I mean, what's gonna or what you know. There are a couple of things you can do, but the thing I'm trying to think about, right, is that, you know, I know that we time limit and you know there are things that we can do. But I'm trying to think because everything that we do is going to be constant amount of optimization, right? And what I mean is that let's say we cut it by 30%. Well, 30%, like you know, maybe we save enough time and we can measure it here, and we say, okay, now whatever we do is 30% faster. But The problem is that it's impossible to tell right now if this time limit exceeded whether 30% faster is, well, fast enough, right? Because we don't know what the limits are, we don't know how tough these things are, and it's just YOLO. So right now I'm just being a little bit lazy, and that like I'm just trying to think about how to optimize it, right? Because okay, let's say before that, let's go over the complexity so that we know we're, you know, I don't care that much, so like I know I'm correct or whatever ish. It's just, you know, there's some constant things that we have to work out. But now we can get over the complexity, right? Well, now this is the same idea, right? This is now 1,000, and this is the case, right? And now how many inputs? Well, now it is now 1,000 times 1,000 times 2, but for each input, instead of doing a loop, we for each input, instead of doing a loop, we do 2 additions, or one addition, 1 subtraction, but you could also say adding by subtraction, or adding a negative number or whatever, right? So now instead of x times l or x times y times l, it is now only x times y, which for 1,000 square it is probably good enough, but apparently not on Leetcode. So yeah, one optimization that I forgot that I could do is that right now we have this last used thing, right? And as a result, it adds a lot of, you know, minor complexity, or not complexity, just like a lot of constants rather, right? But one thing that you can do is always just take the first index. This is a very specific trick, if you will, you want to call it that, but it's a specific idea and optimization, right? Is that you can always just take from the first item, right? So maybe you could have like item 1, item 2, and then now instead of just last use, we just assume, or we just write the last used item is item 1, right? So then now maybe changing it, we can write item 1 is left, maybe, I don't know, let's just say left, right? Otherwise, if item 1 left is equal to 0, meaning that this is not equal to 0, then we return 0, right? Just because then now we cannot take anymore. And then now instead of last used, we can just write the same thing, right? We can write count, we add, or well, we know that items 1 underscore left is greater than 0, so then now we can write g of item 1 left minus 1 item, well, no. So the idea here is that instead, oh no, yeah. Well, okay, let's write the for loop version first, because I think I'm confusing people. So now the for loop version is going to be same idea for streak in range from 1 to min of item 1 left plus 1 to be inclusive, or limit, right? Yeah, and then you do something like this of f of, and now it's going to be item 2 left, because now you want to do this item less. Oh, sorry, the last used item is item 2. I think that's what I meant to write. So then, or another way of saying it is use item 1 now, right? So then now you just swap the order, right? In that here, so you have something like this, because now you want to use the next object first, right? So now, for example, if item 1 is 0, then now you want to use 1, right? So that's basically the idea. And then now here, skipping ahead a little bit, then you can also think of this as, can we add it to g of item 2 left, item 1 left minus 1, and then if item 1 left minus limit minus 1 is greater than or 0, count we g of item 2 left, item 1 minus so something like this, right? And the reason why, what am I doing, right? The reason why I'm doing it like this is because then now, you're making this twice as fast, right? Because now, I mean, obviously the big O and everything, all the analysis is the same, but now instead of ×2, we just remove the ×2. So now we just made everything twice as fast, and also here as well, right? Now we could get rid of one of the functions, which is nice. Because you always just subtract from one dimension, right? And let's just call it item 1, item 2. Right. And as we said, we always only subtract from the items 1, so this is a little bit confusing because we call into this with the swap thing, right? Hopefully this is correct. I mean, I have to correct the bottom part as well, and also the caller function. Because then now we call this plus f of count 1, count 0, right? So that means that the first number is 0, and then the first number is 1, right? Hopefully this is fast enough. Well, I mean, we probably have to clean up some stuff to make sure it's correct, but it is, it is noticeable that I went from 2.7, I think, seconds to 1.2. So we are twice as fast. So hopefully that'll be fast enough time limit wise. Of course, we have to deal with some imprecisions. So we have to figure it out. This part seems okay. And the more beauty is that also, the code is shorter, so should be okay. Huh. But the item 1, item 2 thing is a little bit confusing, maybe. I mean, it's too short to be wrong. Is it just the base case? I'm overcounting, not undercounting though. It's good that this is fast. Oh, sorry. Yeah, I don't think that should fix it, but I just wanted to not have doubts about it, though that wouldn't make sense otherwise. Well, messing up. No, this should be right. What am I doing wrong? Dun dun dun. F. So you want summation of these? I mean, it may be that I swapped the order on some of these. I could see myself getting confused, honestly. This part seems okay. Am I doing this part wrong? Yes, I am. Because on the G part, because I think I double swapped or something. Because we want the summation on this part, right? On the second part, assuming that that's the difference, but then here we swapped it. Okay, I think this is, it's very confusing the way I wrote it, perhaps. Because I think I like double swapped it and there was like a double negative kind of thing. So then just end up being wrong. But yeah, as you can see, this is much faster, right? So let's give it a quick submit. I mean, it's 2 times as fast. Let's see if it's fast enough. I mean, if they need even more, then who knows, right? Hopefully this is good enough. Oh, it's not going with good enough, is it? Oh, well, it barely does, so, yeah. Huh, it's faster than the last time. What did I do? Oh, well, I didn't. See, Java is just so much faster, as you can see. But what did I do last time? I did convert it to bottoms up with the L0 to 2 thing. Oh, that was a really delayed pop-up. But yeah, but that's kind of like a cool trick to kind of get a 2 times speed up. I think another way, like I said, the other way that you would do it is just by writing it this way. So as you can see, it is a bit of a mess. And even here though, you can write the bottoms up as well. And you could even do a space optimization trick, right? But yeah, that's it. So you can get this down to like, yeah, you can get this down even better with DP. But yeah, that's it. That's all I have for this one. I want you to think about just the visualization, right? And once you see the visualization, sometimes these ideas will come into play. And with the visualization, that's how you get other harder ideas as well, right? Like Pure the Playground comics whole trick or variation of the comics whole trick where, you know, you see the curve as you kind of look into the thing, right? Because here, for example, you can see that this is just the sum of whatever, right? But maybe sometimes there's a cost for each one, and then, you know, you can actually do more math that way. But yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, drink your mental health. I'll see y'all later and take care. Bye-bye.